Hello everyone, welcome to Pepcoding. Today we are here to solve a question merge-two-sorted linked list. Okay, so let's go and see the question. Here we are given two linked lists. The first is this and the second is this. Okay, and in the output we have a single linked list merger of these two linked lists and it is also sorted. Okay, so just check out this input. First we have -1, that is smaller, so -1 is at the start. After that 1 is smaller, no, after that 0 is smaller, so 0 is here. After that 1 is smaller, so 1 is here. After that 2 is smaller, then 2 is here. After that we got both the elements 6, so these two are equal, so take any of them. So 6 is here. After that the second 6 is here. After that again when we compare 7 and 17, 7 is smaller, so 7 is here. After that when we compare 15 is smaller, so 15 is here. After that when we compared 17 is smaller, so 17 is here. After that 24 is smaller, and at last 25 is the last node. Okay, so this is what we have to do. We are given two linked lists, two sorted linked lists, and we have to merge these two sorted linked lists, and the resultant should also be sorted. Okay, now let's have a look at the constraint. Okay, let's go. So here we have constraint. So the constraint is the size of the linked list either should it is inside the range of 0 to the 10 to the power 6. It means either the size of the linked list can be 0 or it can be up to 10 to the power 6. Okay, it means the solution should exist in the O of n. Let me explain you this. Okay, we are here. Just suppose the size of this linked list is m and the size of this linked list is n. Okay, if the value of m is 10 to the power 6 and the value of n is 10 to the power 6, if your solution exists in m in cross n, so what will happen? 10 to the power 6 into 10 to the power 6 is equals to 10 to the power 12. Okay, so but our constraint is up to 10 to the power 6, so it won't pass the test cases. Okay, so it can be either m plus n or less than that, it can work. Okay, just suppose m plus n, so what it will be? It will be 10 to the power 6 plus 10 to the power 6. It will be equal to 2 into 10 to the power 6. It is very easy to pass. Okay, so we have to find a solution in this complexity. Okay, so let's go on the board now. I have already written the test cases on the board for you. Okay, so let's go. These are two given linked lists. So what we will do, first of all, we will make a dummy node. Okay, why we will make it? Because it will handle a lot of null point exception cases for us. Okay, after that what will happen? We will make a previous equals to dummy first. Okay, and this previous will lead us wherever we lead it. Okay, so this is this is 1 and this is the linked list 2. We have head here given. Okay, we don't need to change this head because there is a risk. If we lost the head, what will happen? We will lose the complete linked list. So we don't change the head. Either we will use the iterator for this. So C1 will be iterator for this and C2 will be iterator for this. So what will happen here? We will compare. We will compare which one is smaller, either C1 or C2. We can see here C2 is smaller, right? So what will happen in the next previous? What will happen in the next of previous? C2 will attached. Okay, so next to the previous, C2 is here. Now what will happen? This C2 will move forward. So let me make it move forward. Okay, now C2 is here. Okay, after that previous will also move forward here. So previous is here now. Now what will happen? Again we will check which one is smaller, either C1 or C2. We can see C2 is the smaller one. So what will happen? Again the next will be this. The previous next will be this. Okay, again the same thing will happen. Our C2 will move forward and the previous will move forward. Okay, again after that we will again compare C1 and C2 and we see that the C1 is smaller this time. So what will happen? Previous dot next will be C1. So this will be the link. and this will be erased. Okay, so this link is gone now, right? After that, what will happen? Previous will move to the previous dot next. So previous will move next. So let me take this to the next part. The previous is here now. Okay, this is done. And C1 will also move to the next. Don't forget to move C1. Okay, this is also done. Now again the comparison will start in C1 and C2. This time C1 is smaller again. So what will happen? The next of the previous will be C1 and C1 will move forward. Okay, so let's move C1 forward. The previous will come to the next again. So previous is here now. Again the C1 and C2 is compared. They both are same, they both are equal now. So take any of them, it doesn't matter. Okay, just suppose we are attaching this this 6 with this. So what will happen? It will be attached here and this list will be removed. Okay, so this link is removed. Now what will happen? This C2 will move forward again. So C2 is moved forward and this previous will also move forward. So previous is here now. Again C1 and C2 will be compared and C1 is smaller this time. What will happen? Let me make this previous here so we can make a better link. Okay, so the link will be this. And what will happen? Now again the same thing, C1 will move forward and the previous will move forward also. So we are here again, the C1 and C2 is compared. C1 is winner here. So what will happen? This link will be created. Okay, and the C1 will move forward. Let's see. C1 is moving forward and previous will also move forward. We are here now. After that again C1 and C2 is compared. This time also C1 wins. So what will happen? This link is created for previous and C1 is moving forward. Okay, C1 move forward, previous also move forward. We are here now. Now what will happen? Again C1 and C2 is compared. This time C2 is the winner. So it will connect here and this link will be removed. Okay, so this is gone and C2 will move forward. So C2 moves forward. So this link list end here. Okay, what happened now? So C2 move forward and the previous also move forward. Let me complete this first. So previous is here, C2 is here. Now if we simply we forgot to break this link, when it moved for this side, this link was broken. Okay, so this is broken now. This link is also broken. Okay, now we just need to connect previous with the C1 to get the complete link list. Just have a look here. Yeah, whichever list end first, that will be completely in this included link list. Okay, and the remaining link list is already sorted. So what we will do, we will add that C1 or C2, whichever is longer, we will attach that to the previous. So the list will be completely sorted. So this is the complete sorted link list now. Okay, so let's go on the board and write some code for it. We are here. Okay, first of all, what we are going to do, we are going to check if, okay, what we are going to check, let me explain you that also. Just suppose we got two linked lists here. Just suppose if we got a blank linked list, one or two both blank linked lists, what will be the answer then? Suppose we have one linked list but the other linked list is blank, or the both linked list is blank. In both the cases, what will happen? This linked list is sorted. Okay, so if this is sorted, we merge these two merging, what will happen? This will be the answer. Okay, and here what will happen? If both are empty, so what will happen? The resultant will be empty. It doesn't matter. So what we will do, if one is empty, we will return the non-empty one. That will be the answer. Okay, so let's go and do that. Okay, we are here. If L1 is equals to null or L2 is equals to null, what it means? It means either L1 is null or L2 is null or both can be null. So what we will return? We will return the non-empty one. Okay. So L1 is not equals to null. It's like, okay, if L1 is not equals to null, what will happen? We will return L1 or we will return L2. Okay, do you get that? It means if L1 is not null, we will return L1, or after that, if L1 is not null, if L1 became null, what will happen? We will return L2. Okay, so this will handle that case. After that, we have to make a dummy first. So list node dummy equals to new list node. Okay, this is done. Now what we are going to do? We are going to make a previous list node. So list node previous is equals to dummy. Okay, this is also done. So we have completed these two tasks, dummy and the previous one. Now what we have to do? We have to create C1 and C2 as the iterator first. So we are here. Okay, yes, here. So list node C1 is equals to L1 and list node C2 is equals to L2. Okay, this is done. Now we have the iterator. Now what we are going to do? We are going to run the loop until when? Until one of the iterator for the list becomes null. Okay, we will run till the shorter linked list. So until C1 is not equals to null and C2 is not equals to null, this loop will run. Okay, so inside this, what we are going to do? We are going to check the condition as I told you. If C1 dot value is less than C2 dot value, okay, what will happen? In the previous dot next, what will happen? It becomes C1. Okay, and C1 also moves to the next, C1 dot next. Okay, this is done. In the else part, what will happen? It means the C2 is greater or equal. If equal, it doesn't matter. So we will handle that. Previous dot next equals to C2 and C2 will also move forward, C2 dot next. Okay, and when we come out of this statement, what will happen? Now we have to move previous also. Previous equals to previous dot next. Okay, so this is also done. Previous also move forward. Okay, when we come out of this loop, it means one list is ended, like the shortest one is completely iterated. Now we have to link this one, whichever is left. Okay, whichever is left, we have to connect that with the previous one. Okay, so we are here. What will happen? So previous dot next will be, what it will be? It will be the non-empty. So if C1 is not equals to null, so it will be C1 or it will be C2. Okay, so this is done also. Now we have to return something. So before returning, let me tell you something. We have make a dummy, okay, but it is not the head for this list. We don't need to print this. So for that, what we'll do, we will return the next of the dummy, that is -1. So our list will start from this point. Okay, so when we return, okay, let me erase this. Okay, yeah, this is done. So now this will do the work. We have to return the next of the dummy. So our link list will start from this point. Okay, so let's go and return dummy dot next. So this is all code about. Let's go and run this code. This is accepted. Now let's submit it. Yeah, the correct answer. Okay, now let's talk about the complexity now. Okay, so let's go on the board. In here we see what is happening. Let me take the code also, so it will be easy for us. So the code is here. Okay, so code is here now. Okay, so let's go and see. So what is happening here? First of all, our loop is running till the our one linked list became empty. So many of us just assume it will run till the shortest linked list. Okay, but it is not the truth. Let me tell you why. Just suppose we have a given linked list 1 and 1000, and the second given linked list is 2, 3, 4, 5, 6, 7. Okay, so what will happen? Everyone assumes that yeah, this while loop will run until the shorter linked list, but it doesn't work like this. Okay, because let me tell you, this will be the C1, this will be the C2, that is iterative. Now what will happen? It will compare, and the C1 is the winner. Okay, so the previous will connect with C1. After that, what will happen? When we compare now, every time this C1 will reach this point after that. Okay, so after that, whenever we will compare, every time C2 is the winner. Okay, so what will happen after this? This link is broken now. Okay, this link is broken and it is connected to this point. Okay, in the first time. After that, C2 will move. So C2 move. C2 is here now. After that, again when comparing, C2 again wins. So what will happen? C2 will keep moving. Okay, after that again C2 move. After that again C2 move. After that again C2 move. It depends on the value. It depends on the value actually, not the size of the linked list. Okay, so we can say many of us says that the smaller linked list, this loop will run till the smaller linked list, but it doesn't matter. It matters on the value of the linked list. Okay, so we can simply say it will run till m plus n. Okay, after that we simply attached it with the rest of the linked list. Okay, that is the importance of linked list. We can directly attach the part of linked list just by adding a node to that point. Okay, so this saves the time for us. Okay, so the time complexity will be m plus n, or you can say just O of n. I hope you have learned something, you have enjoyed the video. Thank you so much. Please like and share the video and subscribe the channel. Thank you so much.